Hello, honors algebra students and regular algebra students. If you're watching this at a later date, Mr. Lawrence here with another exciting flip lesson. And today we're going to learn about the standard form of linear equations. Remember, linear equations are equations that produce lines when graphed. Notice the word line is hiding in there. I know some of you are thinking, oh, the word ear is in there. No, 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 it's the word line that we care about. All right, somebody else is going, hey, Mr. Lawrence, in is in there. Yes, I realize that. Okay, anyway. Standard form of a linear equation is pretty simple, and it's actually going to allow us to do some shortcuts with graphing. But today we're going to take it slow. We're just going to learn what standard form looks like and how to turn it into standard form. And we're also going to do it with integer coefficients. And I'll explain what that means in just a moment. Okay, and standard form of a linear equation looks like this. When an equation is written, a linear equation is written of this form, we say it's in standard form. What do you notice about it? Well, the x variable and the y variable are on the same side of the equation. We have the x variable first. The a, b, and c are coefficients and constants. A is just the coefficient in front of x, the coefficient. All right. And b is just a coefficient. And then c is a constant because it's a set number. There's no variable attached to it. Oops, I guess it'd help if I spelled constant, right? All right, just make that a real thick S there. Okay, now one thing to be in standard form, A needs to be greater than equal to 0. Okay, um, in other words, we don't want A to be negative. So if I have an equation like this, 5x plus 2y, that equals 7. Okay, that is standard form of a linear equation. We're in standard form. X and y are on the same side. The a coefficient is positive. C is on the opposite side. This one, however, is not in standard form because x and y are not on the same side. Well, we could move it to standard form real simply. Subtract 3y from both sides. Be careful not to make any even apples on the left-hand side. X's and y's are not like terms. We don't put them together. And there you go. Now I'm in standard form. Now some of you might be thinking, hey, wait a minute, the b term is negative. That's okay. The only restriction is on the a term to be in standard form. Why is it like this? Because that's the way somebody made it up, and then math people around the world do it all the same way. That's the beauty of math, is that we all do it the same way. We might have a different word for it because of a language, a different language, but we do it the same basic way. And it's really believed that if we should ever, and I'm not saying this has happened or going to happen or will happen even soon, but if we should ever meet somebody from another world, like an alien, like E.T. phone home, we will probably first communicate with them mathematically because we believe that math is a universal language, meaning that they will have their version of mathematics, which will be parallel to ours. Different words, different symbols, but procedure will be the same, and our math people and their math people will get together and look at it. Now, if we had an equation like this, where we had 2y equals 5x minus 4, I'm not in standard form. Some of you are going to want to isolate and get the y alone. If I do that, I'm going to slope-intercept form. In this case, I want to go to standard form. So I may subtract 5x from both sides. That is not the only possible first step, but it's a good first step. And then I will get negative 5x, positive 2y equals negative 4. But I'm not in standard form because of the coefficient on a. It's not positive. So what I need to do is I need to multiply through by a negative 1. I need to multiply both sides by a negative 1. Multiplying by 1 changes nothing. Multiplying by -1 keeps the number part the same, but changes all their signs. So as I distribute here and here, I get 5x minus 2y, and that'll equal +4. And there is standard form. Now, there's also a standard form with integer coefficients. And you guys are the lucky ones because in honors algebra we talk about this a lot. Minus 2/3 y equals 3/4. Okay. It sure looks like I'm in standard form, but I don't have integer coefficients. And trust me on this integer coefficient thing, we're going to do something in our next lesson that shows you why we might want integer coefficients. Make things a little bit easier when we're graphing. Okay, so I don't want any fractions. I only want integers. Remember, integers are like your negative whole numbers and the positive whole numbers put together. So the integers don't include any fractions or decimals. So when I say I want integer coefficients, I want them all to look something like one of these numbers. Looking at my denominators, can I find the smallest number that all three go into? Well, if I count by the largest denominator, which is 4, and I will stop when I get a number that all three go into. 2 goes into 4, 3 doesn't though. 2 goes into 8 evenly, 3 doesn't. 12, stop. 12 is my number. I'm going to multiply all three fractions. I'm actually distributing on the left-hand side, and I'm just not showing the actual distribution. I'm showing what happens when you multiply. I'm not showing the step before I distribute. Okay, so I'm going to multiply all three fractions by 12/1. When I do that, the 2 and the 12 will simplify, and I'll get 6 times 1 is 6 times x. I get 6x. Here, the 3 and the 12 will simplify to 4. 4 times 2 is 8. 8 times y is 8y, and it's a negative 8y. Okay, here, the 4 will simplify with the 12. 3 times 3 is 9, and there I am. I have standard form with integer coefficients. Let's take a look at one more of those, just in case you're thinking a little magic happened. We don't want magic math class. It might be fun, but all right, let's see here. Let's go with 1/4 y, and let's make that equal, I don't know, 5/12. Okay, so I'm going to find the smallest number, least common multiple, of 5, 4, and 12. So I'm going to start by writing 12, 24. 4 goes into 24, but 5 doesn't. 36, 48, 60. 60 is my least common multiple. I'm going to multiply all three fractions by 60/1. Now, if you're really sharp and you remember that standard form needs to have the a term positive, you might do 2 steps in one. You might actually multiply by -60. That will change the a term to a positive and an integer all at the same shot. But if I do it on one of them, I have to do it on all three. I have to multiply by -60 on all three. Okay, so looking at this first one, I know the negatives are going to cancel. I know that 65th is going to reduce to 12. 12 times 3 is 36, and there's an x there. All right, here, oops, I'm not going to get a positive, am I? When I multiply positive 1/4 by -60, I'm going to get a negative. 4 and 60 will simplify to 15. 15 times 1 is 15, times y is 15y. And then one more. 12 will go into 60 5 times. 5 times 5 is 25, and it's a -25. And there you go. I am standard form with integer coefficients. All right, Mr. Lawrence signing off. Have a good night, everybody.